So now we're going to take a look at the independent samples t-test. So remember, we have 3 different types of t-tests, and in the independent samples t-test, it means that I am comparing 2 groups. So that could be students in a Title I school versus those not in a Title I school. That could be students who are male and students who are female, because there's 2 groups. So in this independent samples, it means that I'm taking a sample and I'm dividing it into 2 groups. So that's kind of the key here. And what I'm going to do is I'm going to compare the average for each group to the other. And what we're going to find is that will help us articulate differences that we find. And so an example research question is there a statistically significant difference in math achievement scores between students who attended tutoring sessions and those who did not? So there's my 2 groups. I have students who attended the tutoring session, and then I had students who did not. So that's 2 specific groups. Then I'm going to take that question and I'm going to write my null and my alternate hypothesis, which would be there is no statistically significant difference in math achievement scores between students who attended tutoring sessions and those who did not. And then the alternate would be that there is a statistically significant difference in math achievement between students who attended tutoring sessions and those who did not. So that's kind of the setting the stage for when we use independent samples. And then it has several assumptions that are similar to some of the other t-tests. And the first is that the dependent variable has to be continuous, or in SPSS, it needs to be scale and have that ruler because it has to be a quantitative number that has meaning. So a test score, a reaction time, your weight, your age, any of those types of things are going to be continuous variables. And you're going to need to kind of include just a brief sentence in your write-up that says the dependent variable, whatever it is, was measured on a continuous scale meeting the assumption required for an independent samples t-test, and then you are going to cite your textbook. Now, the next assumption is that these are independent groups, which just means that one student cannot be in the same group, be in 2 of the groups, in both. So for instance, either you did or you did not attend the tutoring session. You can't be in both of those groups. Either if I had something like maybe Title I versus not Title I schools, you can only go to one school. So that's kind of the key, is that those groups have to be independent, and what that really just means is a student can't belong in both groups. And so here you're going to notice I have some information that when we go into the variable view of SPSS, and you'll see this in the SPSS video, we go into that grouping variable and we look at the values and the labels for that so that we can articulate it correctly in our write-up. So here in the values column, I assigned the number 1 to attended tutoring and the number 2 to did not attend tutoring. So when I wrote my write-up, I clarified that I had students who attended tutoring sessions coded as a 1 and those who did not, coded as a 2, were independent, and you want to make sure you say why. Then we're going to have our citation. So these initial assumptions, there's not a test that I'm trying to run or anything specifically that I'm trying to do. I am just running the test. Just like every inferential statistic, we have to check the outliers. And if you remember from the other videos, the outliers are checked when you run the Shapiro-Wilk NAT test. So you're actually going to find the answer to the significant outliers at the same time that you find out the normality of the dependent variable. And what you're going to do is you're going to take your box and whisker plot and you're going to place it here with your write-up. Then you're going to take your Shapiro-Wilk and place it here with your write-up. And then you're going to state whether that satisfies or not satisfies the assumption of normality. And then same thing, no significant outliers or significant outliers. were identified. So in order to run this test, you're going to go to the bottom of the appendix here, and I have the steps to running this test in SPSS. And so this is the set of steps you will follow before you do your t-test to check for outliers and Shapiro-Wilk. So you'll move through these things to get your output, then you will place your output in the template, and then you will do the write-up based on the output. So we've done the box and whisker, we've got the Shapiro-Wilk. Now we have this additional assumption of the homogeneity of variance. And what that really just means is that the variance for the two groups needs to be the same. If the variance is not the same, it would be like comparing an apple to an orange. They're both fruit, but they are very, very different fruits. So this is kind of us trying to say, are the groupings about equal? Because if I'm trying to understand if there's a difference in these groups, I need to try to keep them as similar as possible. So I can compare an apple to an apple or an orange to an orange. That's what we're really looking for here. But what's interesting about this assumption is you can only do it with the actual t-test. So you cannot run this prior to running a t-test. You're going to have to scroll down and actually conduct your t-test. Then you will put your image for the Levene's table here, and then you will fill in your description here and do your write-up with your citation. So I've got just kind of a brief look at this, but I also have the screenshot. So I'm going to go to compare means, independent samples, and I'm going to follow those steps. And it's kind of going to give me quite a few output tables. So I'm going to get a lot of information. So I get my group statistics table. And so what I'm looking here at the group statistics is it's giving me the mean of each of these groups. It's giving me the standard deviation. And then I can calculate the variance if needed from this, or I can run additional descriptive statistics. So if I look at the mean for math achievement, the mean for the fast track is 14.7. The mean for the regular track is 10.7. If I'm looking at grades in high school, the mean for the fast track is 5.5. The mean for the regular track is 5.83. So the difference in this test is if you're only testing for a difference in math, your table is going to come out with just one variable. This is testing for 3 variables at one time. We are not going to be testing for 3 variables at one time. We are only going to look at them one at a time. So when you're looking at your actual output, it would just be one box with just the 2 rows. Then this is the actual t-test, and you'll notice that the labels of these tests are not always clear. So it does say independent samples test, and so what you're going to do first is you are going to look at your Levene's value. So that's the left 2 columns over here with the F and the sigma value. So if I'm looking at math achievement test, I have 0.466 is my Levene's. If I'm looking at grades in high school, my Levene's is 0.451. So this is looking at different variables. Now again, we're only going to run one variable at a time, so we're only going to see a third of this chart. And so let's go back up to our assumption. And for Levene's, I have an explanation of how to read it. If that significance is greater than 0.05, the variances are equal. If it's less, they're unequal. So I'm going to go back to that output. And here I can see this is greater than 0.05, so my variances are equal and my assumption is validated. This is greater than 0.05, so my assumption is validated, the variances are equal, and I proceed. In visualization, though, I get something that's less than 0.05, which means this is violating the expectation of equal variance. Now, there's a couple things that can happen here. In my statistical preference and that of most textbook publishers and committee members, we don't want you to continue if something violates equal variances as a t-test. This is why we typically say, even though it's only comparing two groups, it is better to use an ANOVA that compares two groups for a dissertation, just because as you're writing your proposal, you're not going to know if the variances are equal or not. That's something you can't find out until you have all of your data prepared and you're ready to enter it in. Then if I'm looking at the t-test, I am looking here at the sigma 2 tail to tell me if it's a significant difference. So 0.009 is less than 0.05. So there is a significant difference in math achievement for those with a fast track versus regular track. I am reading from the equal variances assumed row because my sigma for Levene's was a 0.466, which means equal variances are assumed. In grades in high school, remember the Levene's value is 0.451. That means that I can assume it's equal variance. So when I'm looking at my t-test, I look at the top row, 0.369, which is greater than 0.05, which means for grades, there is no statistically significant difference in grades. In visualization, my Levene's value is less than 0.05, which means that equal variances are not assumed. So I have violated that assumption, and I have to go to the second row to look for my t-test value, and I see it as 0.02, which is less than 0.05, which means that there is a statistically significant difference for the visualization test between that fast track and that academic track. So once you've kind of read through this, these are all the instructions of what I just went through, so you can see how to find everything. We also have that Cohen's d effect size coming back into play. And we also have my significance values. I'm just going to put this one in here right now. And so what's interesting here is you'll note that in that descriptives table, there is a difference between visualization of 6.4 and 4.2. So the means are different. However, what this test just told me, because it is greater than 0.05, is that the difference in those two means is not significant. So that is the key piece, is that while they are different values, they are not significantly different from one another. Then you're going to use this template and you're going to use your output tables and you are going to replace the brackets with what you find in the output tables. What I have also done is I have included an APA write-up that gives you exactly what this should look like based on the numbers within the table that I gave you. Here, we do not get an effect size. However, we can compute an effect size. So what I'm going to actually do is remove that because we don't want to do this. So there are a couple of notes later on about looking at the information in a slightly different way when I'm looking at the normality and if assumptions are violated. So if you do get something that's violated, I've got a couple of notes down here with things that you can do. But most of the time we can still keep moving even if something is violated. We just have to make some assumptions about things like knowing the actual exact values or knowing that we have more than 30 participants. So that is how you're going to work with a independent samples t-test. In the dissertation, we would work on calculating Cohen's d. For this class, that's kind of out of scope, but this packet is for students who were working through their dissertation as well as students in 810. So I do have this included so that it can be put into the dissertation.